Hey everybody, here we go. This is 8.1, average values of a function. So one way to think about average value of a function, it's the same as the average height of a function. Okay, so if we kind of break this down to something that's fairly simple, let's say we look at a rectangle. So we can say the area inside the rectangle, let's just call this whole area, let's use blue, and let's say that's the area of the function. And then how do you find the area of a rectangle? Well, we just say that's the length times the width, right? So length times width. So we know the whole formula for our area of a function. We can say the area equals, and this is all stuff that you know before, but we're trying to prove a point here. Area is length times the width. Okay, so great, no big deal. How does this help for average value of a function? We're trying to find the average height of a function, which we could say is the function value, all the function values, right? We can just say, if we just say plug in x, we get this height, we plug in x, we get this height, we plug in x, we get this height. So we can just keep on going up and saying, what is the average value of all of these functions, right? So normally you would just say add them all up and divide by how many there are. Now, unfortunately, calculus gives us this problem because now we can say, well, I'll add the one between that, and add the one between that, and add the one between that. We can keep on getting more and more functions, or more possible function values. So we can add up all these possible spots, right? So what we can do is we can use some things we know about calculus to make this a little bit easier. So the first thing we know is that how do you find the area under a curve? Well, we know that's the integral, right? From, let's just say we are starting at 0 here, and let's say we're ending at 4. Okay, so we can say that's the integral from 0 to 4 of some function that we have, and let's just say it's f of x dx. Okay, so that area under that curve is going to be equal to, right? It's going to be equal to the length times the width. Right? So what we really want to find, if we want to find this average height, we want to find what's the average width that we need, right? So we need to solve for W. So the best thing we can really do is divide both of these by L, and then we're going to get our answer, right? So we're going to be able to get an answer in terms of W. We're going to be able to get what is the average value of W, because we can say, what is the area divided by the length? So what is the area total divided by how far do we go across this way? And that will tell us the average width, all right? So what we can do is we can say that our function would be the integral from 0 to 4 of our function f of x dx. Instead of dividing by L, another thing we can do is just multiply it by 1 over L, and that's going to equal our width, right? That's going to equal our average width. Okay, so that's kind of our general function that we have for it. So maybe we can do this more generally. So what happens if we have a function that is not quite the same? So if we say here's our y-axis and here's our x-axis, let's go this way. And we say, what happens if we have some function that does something like that? Okay, so we say, we want to know what is the average value for if we start here at A and we end here at B, right? So what's the average value of our function? Meaning, if we were to kind of split this and say, where are we going to be about equal to, right? We'd say, well, we want to say maybe the average value would be about here. Okay, or maybe it'll be a little bit higher, maybe it'll be a little bit lower. But here's how we're going to find it. Here is the average value of a function. Okay, so first we're going to say that the average value, f, and they say AVG for average, is going to equal. And first we need to do the 1 over the length. Okay, so we're going to do this 1 over the length part first. So 1 over the length is really this distance from A to B, right? So if B is the larger one, it's just going to be 1 over B minus A. And then we have to do the integral, right? So we've got the integral from A to B of our function, and let's just say our function here is f of x, right? So we have of our function f of x dx. All right, so our average value is going to be this kind of, where are we going to be on the average if we look at our whole thing from A to B. It's going to have some above, and some below, right? But this is going to be our average value in between. Okay, so our average value is 1 over b minus a times the integral of a to b of our function. Okay, so let's do an example. What is the average value of a cup filled with water that has sides as a parabola? Okay, so let's say we have a cup, right? Looks just like this. So we have this cup, and we're going to say it goes between, we don't want to go over there. We want to go between 4 here. There. So now I'm almost there. 4. There we go. We want to go between here and here. So you have this cup, and I wish I could draw on Desmos here, but I can't really draw over the top. Okay, so we have this cup. It goes from left side to right side. It goes from here and goes back down. We want to say, what's the average value? One way to look at the average value would be to say, when is the cup going to be halfway filled up with water? Okay, that's going to be what we're going to try and find, is when is the cup halfway filled with water? So it's probably going to have to be higher up here than lower down there, right? Because as you get higher, it's getting wider, so we're getting more area as we go further out. So it's going to have to be over 2 is what I'm thinking. Okay, so we're going from -2 to +2 for the x values. Okay, so let's try and do this. So we're going to say we need, how far are we going? So it's going to be I guess I'll do it right here. We say F average is going to equal our 1 over b minus a. And remember, and we're looking at this, b is 2, and a is going to be -2, our x values. Okay, so it's 1 over 2 minus -2. That's kind of weird. Let's do our 2's the same way here. -2. There we go. And then we have to do the integral. I guess I did that in blue before. We'll do that again in blue. So integral from -2 to +2 of our function. In this case, it's x squared dx. Okay, so then we can say that's going to be the same as we get 1/4. And then the integral part, we're going to say that's going to be 1/3 x cubed, and we have to evaluate that from -2 to +2. Remember, we don't need a plus c because we have a definite integral. We've got the -2 to +2. Okay, so we just have to plug in the -2 and the +2 into this whole thing, and we can say, well, 1/4 and 1/3, I can just get 1/12, and then 2 cubed is 8, and then I can do -1/12 times -2 cubed is -8. Okay. So there we go. And then we get 1/8, we get 8/12. I don't know why I said 1/8. I get 8/12 minus -8/12. So we end up with 16/12. And that is the same as what? 1 and 4/12, which we could say is the same as 1 and 1/3. Okay, so we get 4/3, 1 and 1/3. So we can say the average value of our function is 1 and 1/3. So if we go down to about 1.3 right here, it says this is our average value. Okay, now why is this the case? Because you think, oh, well, it's 1.3. Well, really, it should be 1.3 and not 1.4, right? Oh, I fixed it. Now it's back. There we go. So you'd say, why is that the case? Why? That doesn't seem right, because that seems like it's less than what we had said for the cup. So what we really have is, I'm going to draw it over here, is if we have our function here, so we're looking at this thing as our function, and we know it's going up this way and up this way. When we take the integral, we're finding the area here and area here. So what we really found is we kind of did the opposite of our cup. So we've kind of filled out the outside. So we want to say this is the average value for the area underneath. So that's why it's kind of low. So if we want to figure out where it was, we should take our height and we should subtract the 1 and 1/3. So if we want to find this whole thing, we'd say 4 minus 4/3. So it would be what? 2 and 2/3 would be our actual area. 2 and 2/3 would be our So 2.6, 2.7 right here. So if you look at this spot right here, this will give us about half of the cup. All right, so the half of the cup is filled up. So really what we did was we took the 4. Why did I take 4? 4 is the height at this spot. Why doesn't it like that spot? That's weird. Weird. So anyway, when we have -2, it goes up to 4. +2 goes up to 4. So that's the height of our cup, right? So if we go down about 4/3, that's going to be when the cup is halfway filled up. Okay, and remember we got that because when we did our integral, it was the area under the curve, not area above the curve, which we kind of had a problem with. Okay, so there's an example on how to do